Hello student, it is the continuation of the two-dimensional array that we have discussed on the previous lectures. In this lecture, we are going to solve some problems related about the two-dimensional array or in the matrix, where the first problems there where we have taken as a write a program to create a matrix of the dimension m into n for the integer type of the data elements and display the same. So in these examples, we are going to create a matrix of the dimension of the size of m into n. Definitely is going to store as a integer type of the data element. So we'll have to declare an this matrix of the integer type, and we'll have to display the same. So as such, to solve these problems, what we'll have to do first, we'll have to inside the main functions, we'll have to declare first the array, or means two-dimensional array or the matrix. So for declaring a matrix, here we'll have to going to store as the integer type of the data element. So we'll have to declare this matrix integer type. Let's have the a, it have the dimension m into n, but so far at the very beginning we do not know what is the m, what is the n, so we cannot declare a matrix m with have some of the variables m and n, because we know that their size should be the constant. So let's have, we have assumed that there may have maximum 10 rows and maximum 10 columns. So here we have specified that the matrix A with maximum 10 size and 10 row and 10 column. Later on we may take the input from the user, what with the m and n, and this m and n must be lesser than these elements. Now for iteration purpose, as such, we know that for taking the input from the users, we need the two loops. So for iterations, we can take the two variables I and j for the iteration purpose, and to define the number of rows, let's have m, and to define the number of columns, let's have it is n. Now at very beginning, we must have to know what is the size of your matrix. So here you may display the message like printf enter the size of the matrix, that is m and n. You may ask the user. So definitely users will provide the values. So to take the inputs from the user, we can use this scanf. They will have a 2% d, as such, you know, to take the inputs which are the integer type of the two data element. So they'll have a 2% d, one for the ampersand m and another one for n. So we'll have the users have successfully provide the two values of the size of the rows and size of columns. So as the size number of rows and size of the columns, we'll have to create this matrix. So to create the matrix, we'll have to ask the user, please provide the values. How many values? M into n values. So printf enter the integer data elements data elements data elements. So here, to take the input from the users, we need the two loops for defining the rows and columns. So we'll have to specify, as such we have already specified that the rows always start from the 0th index. So 0, the maximum number of rows is m, so I less than m, and after each row, after the first row, 0th row, we'll have to move to the next row, so I plus plus. Now for every row, we'll have to specify there are how many columns. So let's have the j. Columns also start from the index 0, and maximum how many number of columns? N columns. And taking the input at the 0th column, we'll have to take the input for the next column, that is 1, then 2, then 3. So there should be j plus plus. And to hold the values or to take the input from the user, there should be scanf. It will have the %d, and this is going to be stored at the matrix A at the ith row and the jth column. So as a result, when the I will be become 0, So these iterations will take the value as initialized as a 0. So the first element will be I0 0, j will be incremented by 1. It will check 1 is less than n. If it is, then the next limit for the 0th row and 1th column, similarly 0th row second column, 0th row third column. So when all the data elements of every column has been filled at the 0th row, next I will be incremented. Now I will becomes 1, and this process will continue, and as many number of the elements. So there have m into n number of elements. So till now we have successfully created your two-dimensional array, and now we'll have to display the array or display this your matrix whatever you have created. Now you may write the message like printf your matrix is. You can display such messages. It is optional, that is completely your choice. So for displaying purpose also we need the two loops that it will start from I0, I maximum number of rows is m, and I plus plus, because we'll have to display all the rows one after another. So I plus plus, at each row we'll have to display every columns. So j equals to 0, there are number of columns is n, and j plus plus. Now for displaying we can write the printf. We can display as a %d, then we can provide some space, then double quotes close the quotations mark, then we'll have to display that ith row and the jth column, then we'll have to display this. So after displaying the all the column of the first row, so when we move to the next row, so the display should appear from the next row onwards. So for to move the cursor to the next row, we'll have to use printf new line, what we already are familiar with. Now close braces, so it should be normal get ch, it is optional, and close braces. That's it. So in this program we have successfully created a matrix of the dimension m into n, which are stored the integer type of the data element, and we have displayed the things successfully. Similarly, in this program here, I'm not going to write the whole program. Instead, I am going to write only the simple code for write a sum of the two matrices of the size m into n. As such, we know that for finding the matrix additions, the both of the matrices should be the same size. So let's have a matrix A, which consists, suppose, the 3 rows, and let's have is a 4 column. Similarly, for let's have another matrix B, also should be the same size, because this is the primary conditions to find the matrix additions. The number of rows and columns should be the same. So let's have 0, 1, and 2. 0, 1, 2, 3. So in this example, there have a 3 rows and 4 columns. They also have a 3 rows and 4 columns. Now, once we find the matrix additions of these two matrices, we could have a resultant matrix. Definitely it will be the C, which is also the similar type. It means or similar as well as the similar size. So there also be the 3 rows and 4 columns. So it will be the 0, 1, and 2, 0, 1, 2, and 3. So if we find, so it is the 0, 0, it is 0, 1, it is 0, 2, it is 0, 3, it is 1, 0, it is 1, 1, it is 1, 2, it is 1, 3, it similarly it is 2, 0, 2, 1, 2, 2, 2, 3, similarly it is 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3. So the resultant matrix will also have the same rows and same columns. So it will 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. Oh, sorry. Is a 1, 0. It is for 1, 1. It is 1, 2. It is 1, 3. It is 2, 0. It is 2, 1. It is 2, 2. And it is 2, 3. Now, how we have computed the value of C0? So if you take at the C0 and 0th row and 0th column, it is nothing but the addition of this 0th row and 0th column of the matrix A with the 0th row and 0th column of the matrix B. So it will be the A of 0 0 plus B of 0 0. Similarly, suppose if you wish to find out this value, like C of 1th row and the 2th column, so it is nothing but this value, it will be equivalent of the addition of the matrix A of the first row and second column with the Bth matrix, the first row and the second column. So it's also with the same row and the same column of the matrix A, similarly the same row and the same column of the matrix B. So what I want to analyze, it that if we wish to find out the resultant matrix for the ith row and the jth column, it is nothing but the addition of the eighth matrix of the ith row and the jth column. Similarly, it is the addition of bth matrix of ith row and jth column, isn't it? Okay, now to finding the addition of these two matrix, so first we'll have to create a matrix A and matrix B. How we can create a matrix A? For by using the two loops that we have already discussed here. Similarly, for the matrix B, we can also create in the matrix B like similar these fashions. Now once we'll have the A and B, we can find out the resultant matrix C. For resultant matrix C, we can also use the two loops, that is for I, it will start from the 0, I less than equals to m and I plus plus, and for the z every row there have a that many columns, so j equals to 0, j maximum n columns and j plus plus. And for finding the resultant matrix for the ith row and the jth column, it is nothing but the addition of a ith row and jth column plus b ith row and jth column. That's it. You will have a resultant matrix Cij. And now once the resultant matrix will be created, we can easily display your matrix, the resultant matrix C, in this form. We need the two loops. We can use the printf. Instead of A, there should be a C, and printf new line. We can get it the resultant matrix C. So simple. Hope you understood this one, and you can complete this program by yourself. You can write the entire program by yourself. Here our first work, it would be create a matrix A first. First of all, ask the user how many number of what is your m and n. Ask the user the size. Based on that, create a matrix A, then create a matrix B, then use this statement for matrix additions of these two matrix A and B, and it is stored at the resultant matrix C. Now once it will be done, now we'll have to display the resultant matrix. For displaying purpose, we can use this similar type of the loop for the displaying purpose. Then I need the two loops for the ith row, this jth column, then for displaying the cth I jth value. So this way we can display your resultant matrix Cij. Now it is your assignment to complete this program.